Hello,
Here we go. Yesterday, remember we're doing quadratic equations. What does a quadratic equation have? It is a parabola. The shape of the graph is a parabola. Very good, Hayden. It's like a U, or it could be upside down and it'd be a N, a smile or a frown. Okay. Then it has an x squared, right, Hayden? Not just an x. So now it has an x squared. I can't really take you seriously. Okay. So we're going to move on today a little bit, and then I'm going to go back and do yesterday's as well, because I did not record yesterday, like the one problem we did. Boys, shh. Y'all are talking while I'm talking. Okay, this has an x squared, correct? So it's the shape of a parabola. All right, boys. It has moved where? Boys. I'm about to have to move y'all.
It went down 5.
It moved down 5. Do y'all remember transformations of graphs? If it had a plus 5, where would it have gone? Up 5. All right, I'm about to show you the graph in a second, but we're just going to talk about it for a second. What is this one? What is this one, huh?
A pen?
Who doesn't bring a pen to school?
I don't use pens, I use pencils. So
Okay, where does this one move? Right 4. Very good. This one moves to the right 4. How did you know, boys, that it went to the right?
Because it's
Okay, that's one of the answers. Okay, because it's a minus sign, it's opposite, because it's with the x. When it's with the x, it moves on the x-axis. That's right or left. This one is not with the x. Okay, it's over there by itself. That's how you know it moves up or down. Now let's look at the graphs and we'll talk about a few other things. So the red graph, what in the world is the red graph? It's just the x squared graph. If I was to graph y equals x squared, it goes through 0, 0, 1, 1, and then it makes this U. Now I'm going to take that same graph, and we said this one's moving down 5. There it is. Okay? Something we learned yesterday, just barely, is that the vertex is like that bottom point or that top point. This one was 0, 0. Well, this one's moved down 5. So where is that at? 0, negative 5. All right, what is the axis of symmetry? That is your x value. What's my x value? 0. This one's just 0. My x value is 0. Let's move right here. Again, the parent graph, x squared. So it's just this u right here. And y'all told me it went to the right 4. So 1, 2, 3, 4. Same graph. Just moved over 4. So now its vertex is over 4, comma 0. What's the axis of symmetry? It's the x value. It's 4. X equals 4 would be your axis of symmetry. Are we kind of getting this? And yeah, you can use your calculator. You can graph that on your calculator and it'll give you these ordered pairs. But what you have to find, y'all, you can't have half of a parabola on your graph. What do you need? The other half. Okay, does everybody understand that? It has to be symmetrical. So you'll have to find the axis of symmetry. That's where you're going to graph it. I just got the T reference. Took me a while.
What's the reference? What are they?
She has a jug of sweet tea. Did you notice that?
I knew.
I mean, I knew who they were.
Who
but
are they?
The Phil and who? Wait, which ones?
They're really
Well, I didn't know what
Wait,
that was.
okay,
This one
not
references?
Phil.
I don't know what I said.
What, Willie and Uncle Si? Okay,
So
Phil
you also
died, didn't he?
do, like,
Yeah.
notes or
Anyway, but I mean, I knew who y'all were.
You know,
Does he
Uncle
know
Si's in the
what's
hospital.
No, I didn't know that.
He is?
My grandpa's
Yeah,
friend.
but let me go.
I mean, I knew who y'all were when y'all got out of the vehicles today. But the T, I didn't notice. I haven't watched that in a while. Okay, y'all, let's go on to this one. Where does this one move?
Up 3.
Very good. Where does this one move?
Left 1.
Left 1. If I was to graph them, now these, I'm going to graph them without a calculator and then with a calculator because we need to get used to this. So if I graph up 3, I would just go 1, 2, 3. And since I haven't changed anything, they just go up 1 and over 1. Okay, I didn't draw that very good, symmetrical. What's the axis of symmetry? Well, what's the vertex? 0, 3. What's the axis of symmetry? What's the x value I just wrote? X value. 0. Over 0, up 3. Oh, yeah, I did graph it for you. It just looks funny. Okay, where did this one move? Y'all said left 1. So it's right here. And then we just go to these 2 points and graph. My vertex is -1, 0. So where's my axis of symmetry, Hayden? X equals?
X equals -1, 0.
What's x?
X is -1.
Yeah,
And then
okay. So
0.
your axis of symmetry is -1. There's no 0.
What I just said,
Okay. Now, if you were to graph it with your calculator, boys, y'all make sure y'all are getting this, okay? Y'all are not asking me on this test whenever you have one. Okay, if I graphed, what does it say? X squared plus 3. X squared plus 3. See? It's going to move up 3. How do you get those ordered pairs? You go to the table, and then you have to find what 3 numbers would you pick? And tell me why. Kenan, try and take a guess. What 3 numbers would you graph?
0.
Okay, go ahead.
0, 1, 2.
Okay, if you graph 0, 1, and 2, these numbers are 3, 4, 7. So you're only seeing that side of the parabola. That's not right. Okay? Somebody else.
-1, 0, 1.
Okay, -1, 0, and 1, you are going to see the parabola. Do y'all see how these numbers start repeating?
What do we try to tell them to whittle away?
Okay, wait, stop. Okay.
What do we do?
So, does that make sense if you use your graph? Alright. Which you're going to want to use your graph on your calculator eventually. Is everybody good so far? Boys, do y'all have that so far? What is wrong with this chair?
It's not rolling.
It's not. It's on this
What
tail.
happens if you do x3 instead of x2?
I think it's broke.
You're going to stain your chair gold.
No, I'm sitting on a beach towel. Okay, what happens if it's what? Thank you.
If it's x3,
X3. Oh, that's a cubic function, which we haven't learned yet. Okay. Now, next one. Here we go. These are the problems that I like. What's the vertex, the axis of symmetry, the maximum, the minimum, and the domain and range of this one function? That's a lot of stuff, right? So they want me to, I can find all that without the calculator. All of it, literally. Okay.
What do we?
You got me saying that.
What do we?
I did not like that though. I don't even know what y'all are talking about. Hey, anybody, tell me what the vertex is. Anybody?
What do we on the statue of liberty?
-4.
No. Where did? Okay, it's got a -2. Where did it move? Somebody tell me where it moves.
Left 4 down 2.
Right 4 down 2. What's your vertex? 4, -2. See how we got that? Whenever you say where it's moved, that's the vertex.
Then
You
why
just
did you tell me not to say 0 the other time.
because I asked for the axis of symmetry. This is the next question in a second. 2 different things. The vertex is where do you move it? Well, this is the -4. That means right 4. That means down 2. Does that make sense? So when I go to write my vertex, I'll write it up here. My vertex, that's our first thing we're going to do, is right 4, down 2. Does everybody understand where those numbers came from? Okay.
I can't name this. Where do we get that? Because when I see it, she says, where do we go?
Okay, what's the axis of symmetry, Hayden?
4.
4. It's x equals 4. That's your axis of symmetry. All you have to do once you get your vertex, it's going to say, okay, find the axis of symmetry. It's just the x value. That means it's symmetrical around x equals 4. It's going to go this way and then this way at x equals 4. Okay, is it a maximum or a minimum? All right, Hayden, which one of these would be a minimum and which one would be a maximum?
Minimum would be the right, maximum would be the left because it's like that's the max point and then it goes back down.
Yes. So this is the maximum. Like if you were climbing up a hill, wouldn't you be at the top of the hill? That's the max height that you would be at. So when it goes like this, that's a maximum. What do we call this? A minimum. You get to the lowest point. Minimum, Kenan, is when you can get to the lowest point. Maximum is when you can get to the highest point. Now, how do you know? If it's negative, if it was negative out here, it would be a frown. right? Negative means you're negative, you're pouty and frowning all the time. Okay? When it's positive out here, it means you're happy, and what kind of person is happy? They make a smile. Does everybody understand this? Hayden, you get this? So, this one is positive, so which picture is it, the left or right?
But what do they want me to glass?
So upside down.
Okay, if it's positive, is it a frown or a smile?
Smile.
It's a smile. This is a positive number, so it's a smile. Is that a maximum or a minimum right there? It's a minimum. So that's how you know if it's a minimum. It matters. It matters because we're going to use the calculator. We can find all these answers on the calculator as well. But you have to be able to tell the calculator if it's a maximum or minimum. Okay. And
How
yeah,
do you get the absolute value bars again?
math and go over one. Okay. Then, what is the maximum? What is the minimum point? We already said it. What is it? It's the vertex. It's 4, -2. I think I heard people say that. It's 4, -2. That is the minimum value. We usually don't write this again. Usually I just have you say, Hayden, please quit talking to them so they'll learn this. So, vertex, axis of symmetry, and then you would just say minimum. I don't usually make y'all write the vertex again. Okay, the domain and range. This is the tricky part. Okay, well actually the domain is the easy part. Okay. The domain, so when you have a graph and it's going like this, it's going up, but it's also going out forever and ever. So your domain is all real numbers. Does everybody understand that? Always, on all these. If it was going down, it's always going out as well, forever and ever. Does everybody get this? So your domain is always all real. I just put an all and then a capital R for all real numbers. Everybody good with that? Because it's always going to go out forever and ever. It goes to the left and it goes to the right forever, whether it's a frown or a smile. Okay, the range is the hard part, but all your information is here. You said it's right here and it's going up. So what is your y value? -2. That is the lowest point it goes. So it goes up from there. How would you write that? Y goes up from -2.
Y is greater than
Y, but you're going to also put the equal to. That is your range. So the lowest point is -2 and it goes up from there. The range is always going to be a greater than for a minimum. What's it going to be for this one? That's going to be a y is less than. This is going to be a y is greater than. Whatever the y value is, it's all right here. All your answers are right here. Axis of symmetry, your range. It's all right there. Okay? Do we kind of get this? It's the same thing over and over again. We just change our numbers. Okay, I think that's all that it wanted on that one. That's one problem. All that information.
Cool. So
And then that didn't even include-
that's an answer.
Yeah, so I think on your test, which I'm pretty sure, actually I'm not sure, at some point, and it might be at this point, Algebra 2 gets tougher and tougher and tougher, and so sometimes I split chapters. Like logarithms, I won't split that chapter. That one's a short one. But this may be one of the chapters I have to split into 2 tests. We'll just see. But it's an extremely important chapter. I think a lot of this would be on the ACT. Me personally, I think y'all are getting through a lot before the ACT. I hope. Okay, let's look at the next one. We're going to do the same thing. And look, we don't even have to graph any of it. Okay? Boys, y'all make sure and that y'all are paying attention because this is definitely doable. Okay? So the first thing it says is what's the vertex? So look, I'll write all the little things we have to write. Vertex, axis of symmetry, max or min, and usually I just like circle that, and then I'll say domain and range. Okay, domain, what is it for every problem? What's our domain for every problem? All real numbers.
Yeah, what you said.
All real numbers.
Yeah.
That's our first. We can just do that anyway. What's the vertex? Where does this one move Edward?
8.
No. Where does this one move Edward? Where does it move?
No idea.
Somebody else.
Left one.
And
Up 4.
left one up 4. That is the vertex.
Well, I get
But
that.
instead
I
of
can
left
see
one, what do we represent with a left? the negative sign. So you just said left 1, up 4. -1, +4. Does that make sense? That's your vertex right there. -1, +4.
I can't even see those numbers. I
Hey,
see the blue.
What's the axis of symmetry? Somebody else over here. The axis of symmetry, boys, it's your x value, so it's -1. Alright? That's all it is. X is -1. That is your axis of symmetry. Is this a max or a min? Let's look at that number out front. Cannon, what's that number out front? Cannon, what's the number out front?
I see them both. No,
What's the number out front?
-1.
It's -2. But so is it a max or a min? It's this number right here.
Man,
Okay, so is it a if it's negative, is it happy or sad?
sad.
So it would look like that. So is that a max or a min?
Man. Max is up top.
Yeah, max. So maximum at -1, 4. Okay. We already did our domain. Now what's our range? So since it's a maximum, boys, stop. Okay, since it's a maximum, we don't go above that, which means what sign?
Negative.
It's the less than. So we've got y is less than or equal to, and what was the y value?
Negative.
No, look up here.
4.
4.
Yeah, quit. You're
All right, go to your seats.
No, I'll go.
No. Yeah, y'all are going. Y'all are going. Ain't nobody got a broke ankle. Y'all can go sit in your seats. Yes.
How is it a maximum if it's a negative?
Because a maximum negative goes this way. When you graph it, it's going down. Because think negative goes down. So that's what's happening. The graph is pointing down. So then you're at, that means that to be right here would be at the top. That means it's the max height. Does that kind of make sense? If you were here in the valley, would you be at the top or the bottom? Then that's a minimum. That's the lowest you can go. You'd be at the bottom. Maximum. Boys, y'all should have been done
I'm
already.
up this traffic, Samantha.
Okay. Let's see what we have next. Let's use vertex form. Let's see where it's moved and graph it and do all that stuff again. Okay, it's the same thing. This one, we're doing great on time. I might give y'all one to try in a second, and I will have y'all graph it, okay? So this one, y'all tell me the vertex. What's our vertex? 1, and then 3. Where did we get that? Right 1 and up 3. So if I was to graph that
Wouldn't
point,
that be negative since it's -1?
no, it's always opposite when it's with the x. So yeah, it moves it because it's supposed to be a minus sign.
Yes, ma'am.
So that's why. So you would go over 1 and up 1, 2, 3. That's the vertex. Everybody good so far? All right. Now let's see. What is the axis of symmetry? It's not asking for that, but we're gonna go ahead and do that. The axis of symmetry.
Lily Gio's not in here. Not Lily.
Lily McCoy.
Oh, here she is.
What's the axis of symmetry? X equals what? Yeah, 1. X equals 1. Okay, is this a max or a min?
It's a.
It's a what? Max? Why is it a maximum? Because it's negative. Alright, it's going down, it's like a frown. What happened?
It's a photo release one from our robotics files.
Oh, okay. I was curious. I was like, did you pay attention to? That's what I was thinking. Well, somebody did yesterday.
Yeah.
My sister.
Oh, I didn't know that one. Okay, it was a high schooler. Okay, anyway, I'm recording. I need to quit talking about me. So it's a maximum. It's a frown. If this number right here is negative, then it's a frown. And that means you would be at a max. So I'm going to write the word max. All right. I'm not going to do domain or range, but what would the domain be? All real numbers every time. Domain is all real numbers. Okay? And then since it's the max, it would be y is less than or equal to 3. But I'm not going to write that down. It didn't even want all this. I want to graph though. Okay? I want to graph that. The best way is let's get out our calculator we will type it in just like they have it typed in. And what numbers do I have to use? We already found our vertex, right? So it's numbers around that vertex. Does that make sense? Yes, no, maybe so. Okay, so we would do y equals, I've got a -2, I have x minus 1 squared, and then plus 3. Is everybody good with how I type that in? It looks exactly the same, and then double check. And then if I press graph, it has moved to the right 1 and up 3, and we already said it was going to be a maximum. So if you ever forget, you can graph and look at it and see, is it a maximum or a minimum? Okay, now what else do I need though? I need some more points. How do I get points? Yep, second graph. And we're going to look at some points around 1, 3. And notice Cannon, because I don't, one of y'all asked a second ago, how did he get that? How do you know what 3 points to use? Where does it repeat? Do you see where it repeats? 1 through 1? That's what you're looking for. So 0, 1, over 1 and up 3, and then over 2 and up 1. And then we could do another one if we wanted to, 3, -5. Kind of get an idea. Oops, that one was still. Anyway, there's our upside down parabola.
Miss Bethany had a question. She was wondering if Bailey Borders was in beta.
I don't know.
She's typing that thing for homecoming.
I'll have to look and ask her. I mean, I'll have to either look or wait. Bailey's not here, is she?
Yeah, she's here now.
Hey,
Oh, she's here now. I will look in just a minute and find out.
Alright.
I can't remember. Okay, there's our graph. Everybody good with graphing? Yes? Y'all are. Oh, were you not done writing?
No, I'm fine.
Okay. All right. Let's see if I have anything else. I do. Last problem. Okay, here is a picture of a dolphin jumping. Okay, it says, what's the quadratic function that models the path of this dolphin jumping? It does tell us that the vertex is 3, 7. Okay, that's that tip top point. So how would I, let me go over 3 and up 7. All right, so y equals, how would I write this equation?
X minus 3.
Very good. X minus 3 squared. Then what?
Plus 7.
Plus 7. Then I need to find another point. I'm wondering what they use. Over 8 and up 5. Do they solve it out? Let me see if they solve it out. They do. They didn't use 8, 5. They used
-1.
4 and 9? Or no, did they use 9 and 4? So maybe, what point did I say?
8, 5.
Does that look like it's going through 8, 5? It did to me.
Yeah.
They use 9, 4. It also looks like it's going through 9, 4. I'll do 8, 5. So, y'all, here's the problem. You have to find the number that goes right here. Okay? So, and there's a way you can do this. I'll teach it to you maybe another day. That you can enter a bunch of these points in on the calculator and have it find the formula for you. You use stat and tell it to find the quadratic. I can show you that one day. The way you would do this, how am I on time? We're okay. You plug in an ordered pair. I picked 8, 5, right? So 8 would be my x value. What would 5 be? If I go over 8 and up 5, 5 would be my y value. And then what am I left to find? That number right there. Does everybody understand that? So that's how you find it. So this one's a little bit harder. So we would have, oops, I just told you, y is 5. X is 8. Okay, then what do I do? What's 8 minus 3? 5. What's 5 squared? 25. So I have 25a plus 7. How do I solve for a?
Divide by 7.
Not divide by 7. move your 7 first, but you subtract it. So you get negative 2 equals 25a, then what? Divide by 25, and that's your a, negative 2 over 25. That's a weird number. So that would be it. That looks definitely weird.
I thought they got something else.
Did they? If they used 9-4, they did. If they used 9-4, they would have gotten
Negative 1 over
6.
Yeah, that's what they got. 'Cause
Negative
they
what?
used the 1 over 12, but that's because they used the
They
9
used 9 and 4. So, and theirs may be more exact. I just thought that it looked like we were at 8-5, but if they picked 9-4, then it would be a little different. But close. Negative 2 over 25 is very close to negative 1 over 12, right? If you doubled 1 over 12, that would be 2 over 24. Really, really close to what I got. Okay? I just can't reduce that one. Okay. I think I'm done. Yay. Y'all seem like y'all had enough.
She's supposed to start pulling out math problems.
Oh yeah, I can pull out some math problems. All right.